we're talking about a lot of traffic going across most networks nowadays. Gigabytes, maybe more. So when you're gathering information across the network, you want to make sure you grab only what you need, but you do want to make sure that you get what you need, because once it's gone, quite frankly, it is gone. So you want to be careful in dealing with network data in that sense. Excuse me. And then collecting everything like a full packet capture should be done only for short durations, because your devices will fill up very, very rapidly. And generally speaking, what you're going to get for a return on just terabytes of data like that is not going to be worth it. So chances are you're going to want to hone down what it is you're trying to capture and filter out things that you know, if you don't want multicast and or broadcast traffic, put a filter in there to get rid of that. You don't need that. You don't need ARP traffic. You don't need ARP traffic. Get rid of it. If you're looking for HTTP, maybe that's what you should filter for, explicitly HTTP, TCP only, or UDP only. But you have to be careful. If you mess that up and you don't get what you're really looking for, now you've run it for however long and the data you have is pretty much useless, right? Or it's not, maybe it's not useless, but it's not useful for what you were trying to gather it for. So be very careful when you're dealing with network, excuse me, data collection, right? So NetFlow data, it's actually a proprietary protocol that Cisco developed. And it's used to track and examine traffic, network traffic. Excuse me. But it's not everything. It's a specific set of information. It's almost like the metadata of the traffic traveling. And you're able to make a lot of mapping or get a good picture of what's happening on a network based on NetFlow data. It normally contains the source and destination IPs, right? The ports and the protocols being used, the number of packets and bytes that have gone across. So that's where kind of it's metadata-ish, right? The start and end times of things going across there, and the routing information, right? And you can get a baseline if you start it under would consider normal conditions, and then you're able to look at this information and see if you have some abnormal traffic patterns, whether it's a spike or maybe it's a reduction. Why isn't this information going to this server? Why is it suddenly not doing what it normally does? That could be being siphoned off to do something else, right? So it could be the opposite of a spike. Look at it as data exfiltration, possibly, if it's heading out of your network versus somewhere in between. But then if you're looking at either a long-term or lots, I'm just going to try to say voluminous communication between internal and external hosts, that's obviously a sign, right? You shouldn't be, none of the machines should be talking unless there's an established link of some sort. Under normal circumstances, a machine on the inside of a network should not be talking for long periods of time with a machine that's on the outside of the network, and certainly there shouldn't be a lot of communication, and that could be a signal for exfiltration of data, or it may be, if it's a long-term thing, some of your hosts may be compromised and it may be part of a botnet, and it's communicating with the command and control host at that point. So packet capture, or PCAP files, right? These are actually capturing what it is flowing across the wire as they traverse the network, right? They have a ton of information because they are the actual pieces of information flowing. So if you have data fragmentation on purpose, so to speak, people are trying to obfuscate what they're doing by fragmenting their packets in such a way that it doesn't look like normal traffic, or it's very hard to figure out what they're doing. If you do a packet capture, full packet capture, then you're going to gain all the fragments, and then you'll be able to piece that together. Whereas otherwise, you may not be able to determine what's going on. Of course, there's the source and destination ports and addresses. We're talking about the flags that are set. You'll actually have the data the packets, the data portion of the packets themselves, right? And you'll have full session data for communication if there's a connection, a TCP established session. You can get, excuse me, full session data as well. Okay, so here's a very key difference. Capture versus display filtering. When you have a network capture software like Wireshark, if you've ever heard of that, TCP dump in the Linux world, although that's very difficult to kind of watch because it just flows across your screen very rapidly normally. There are two different types of filters you can put in it. You can filter the output, right? You have a ton of stuff that you're gathering and you only want to see ARP traffic, HTTP traffic, whatever it is. You can put that in your filter, but the rest of it continues to go. You can continue to collect the other pieces. The capture filter is when you want to pare down what you actually pull in. And so if you say no multicast and no broadcast, it won't grab that. If you only want port 8080, it will only grab port 8080. And if you're interested in port 25 for SMTP, mail traffic, and you accidentally type 22, you are not going to get 25, right? So, and once again, since this is network-based, once that stuff's gone across the wire, you're not going to get it. So be very careful when you're dealing with capture versus display filter, in that you are careful with what you're putting in each of those, and not so much right for the display one, but in particular for the capture one, you may want to test it and make sure in an environment that you know what the traffic looks like. If you put your filter in, you know what you're supposed to be getting, you'll want to test that out. This is, once again, one of those issues in the planning and preparation portions where if you know you want to start creating some filters, ready-made, so to speak, filters to slap in there, to grab, you'll want to test those ahead of time so you don't accidentally take those on site, use the wrong thing, and then miss some valuable information. Excuse me. And this is the other end, right? Large networks and a sniffer, heavy traffic. Your hard drives will fill up very, very quickly if you ask for everything, if you do a full packet capture, right? And then on top of that, too much traffic, it's just going to get in the way. It's more stuff you have to parse through. It's like the bigger haystack that you have to go through to find your needle. So why do that? Some of it can be done with filtering, and some of it is where you place the actual sniffer. So the closer you can get to what it is you're trying to listen for, the better off generally you will be. If you need a larger swath, it's going to just have that much more stuff flowing through it, so you'll want to use your capture filtering at that point to minimize or at least get as close to only the data you need as possible, and that way you don't fill up your hard drives with unnecessary packets. Okay, collector location, you want to get as close to what it is you're actually trying to pay attention to. If you're trying to cover an area, like the DMZ in general, you may want to connect it to the switch above, and I'll just use that as not truly a physical, right? It's not above it, but upstream of it, if you will. You want to place it upstream so it can capture everything. And yes, I'll get to it a little bit later, but a switch generally only allows traffic going to that particular port to come out, but you can set up what they call a span port or a mirror port, where multiple ports or the entire switch, all that information flowing out there will get mirrored, and you'll get a duplicate copy flowing out in one particular port, and you can gather network data using that. Understanding the network topology and, of course, how infrastructure pieces work will be very helpful, right? If you happen to have, and I'm guessing most larger networks don't use hubs anymore, but if you happen to have a hub takes one input and it actually sends out all other ports. So it has a built-in mirroring function. It's horrendous for collisions, and it makes things in a network relatively slow. But if you happen to work with a smaller organization that may not have switches, they may have purchased hubs. I don't know if they would anymore, but you understand how that works, so you can take advantage of that if you need to. And the topology piece, if there's a DMZ, a demilitarized zone, a lot of networks, if you're not familiar with a DMZ, a lot of organizations have an area that's protected slightly differently, and most of the servers or devices in there are hardened in a way and also protected in a way and watched in a way that allows, if something should happen in the demilitarized zone, they're able to handle that better than the regular hosts, the regular user machines. You put those inside, even deeper back from, say, your firewalls. You may have an internal firewall. So understanding how all of those pieces in a enterprise level network works will help you understand where you want to put your sniffer or your tap and gather the data you need. Right? And same thing, you want to use nice focused questions. What are the hosts, your hosts of interest? Are they hosts? Are they servers? What are you actually trying to pay attention to? Right? Is it internal, external communication of interest? Is it outbound, inbound stuff? Or you want both directions? Right? What type of traffic? That's where that filtering will come in. How broad or narrow is capture going to be? Right? Are you trying to get every single thing because it hides well within that traffic and you don't know exactly what it is? Or do you know what it is and what type it is, and you can actually point at it and gather focused data? Okay, so what can a device see, right? And have an understanding. I kind of already talked a little bit about the fact that you don't want to make your haystack any bigger than necessary, right? And obviously not every device in the network can see all the traffic. And this is the same thing I was talking about. If you're dealing with a switch or a router, right, or a host, depending on where you want to listen to things, you have to understand how that works. On a network, how does a computer, a host, work? Does it act like a router, or does it act like a switch if you connect? I'm sorry? Oh, did somebody say something?
Does that act like a switch?
Actually, it host to host, it acts like a router. Actually, yeah. So whenever that's the reason that whenever you connect to computers with each other directly, and instead of through a switch, you have to use a crossover cable because you have to flip the connections. So a computer by itself actually acts in a routing. If you look at it as a network device, when it deals with data, it acts as a router. So understanding that when you're going through and will help you with your collection efforts. Generally speaking, the most important factor when you're setting up a sniffer is going to be location, location, location. Right? You can't get information if the type of traffic that you're looking for does not traverse that line. Placing the sniffer there will not magically. Not everything goes everywhere. Packets travel in lines that are established. It's trying to get to a destination IP address or a destination a MAC address, actually, eventually. So understanding that, placing the sniffer in the right place will be key. Individual hosts, right? Only traffic addressed to that system, unless your NIC is set up into a promiscuous mode, and then it will see not all traffic, but all traffic that traverses the line that it's hanging off of. And then the router and switch, the mirrored port or span port that I alluded to earlier, will pass all traffic that's flowing out of all ports on a switch into that one port. But you should be aware of potentials for VLANs. Switches are set up in such a way that you can have virtual LANs, separate subnets, if you will. You could have a 10 dot whatever network and a 192.168 network, maybe a 172 network coming off of switches. And if you only mirror a certain set of those ports, and maybe that's all you want, it will only give you that packets that are flowing into that particular VLAN. If you want it all, you'll have to make sure that you explicitly set it up as such so you can have access to the VLANs. Okay. Probably a little tough in the back. Well, maybe you can look back there. So this is just a simple network. So I'm just going to ask, if I want to sniff traffic where the clients or the hosts are located, where might I put that sniffer? Where would you think would be a good place to put that sniffer? Anybody?
Switch 3.
Sorry?
Switch 3.
Switch 3, yes. Hanging off of, well, I call it hanging off of. I'm not sure that's an appropriate, it's not the technical term, certainly, but we use that a lot, certainly. Switch 3 here, so you can catch all the traffic that's coming here to reach, and I apologize, to reach these computers, and of course, just 3. So you would want a span port here and gather your data. That's correct. So if you want to collect data going into your DMZ, where would you want to put your sniffer?
Switch 1.
Switch 1? Yep. Switch 1. Want to hang it off, and that way anything going to your mail, if you happen to have an outward-facing, well, not an outward-facing database, but a database connected to your public-facing web server, then you'll want to capture data. What might you be able to get there? If you have a public-facing website, might be able to catch maybe a DDoS, if people are trying to beat up your web server. So you might be able to capture that and be able to see that as it's coming in. Right? And if you want to capture all your internal database information, traffic going to the internal web and database, in addition to your clients, where would you want to put your sniffer?
Router 2.
Router 2. That's right. Good. Yep. So you can understand, right, why these are key. Because if you don't understand this topology, right, not everybody, I don't know, people here have current and up-to-date network topologies on the network right now? People who are here that kind of take care of networks? Kind of, sort of, no? Right? So generally speaking, the admins are the ones who really know what's going on, right? So if the response team shows up, really, you got to go talk to that system and that network admin, because they'll know, even though they have pictures like this, and they'll go, oh no, we moved the mail server over here, and we moved this database over here. They'll know the ins and outs of their network. So, but understanding this will help you gather the information you need and not get too much, and certainly, very importantly, not miss what it is you really want to get at.